Welcome to Homework Lib.
Hi. So in this case, we want to apply Hess law in a certain way in order to find the delta H for the following reaction. So we have 3 moles of iron 2O3 solid plus CO as a gas. That is going to produce 2 equivalents of iron 3O4 as a solid plus CO2 as a gas. Okay. So the reactions that we need to use in order to get this are the following. We have 4 times iron solid plus 3 of O2 gas. If you notice, this is 2 times the formation enthalpy for iron 2O3 as a solid. We have carbon solid graphite plus 1/2 of oxygen gas producing CO gas. This is the enthalpy of formation for CO. Next up, we're going to have the enthalpy of formation for iron 3O4. And finally, we're going to have the inverse of the enthalpy of formation of CO2 gas. Okay? C solid graphite plus O2 as a gas. Okay? And we're given the values for delta H for each of them. So delta H naught over here, we're going to have minus 1652 minus 110.5 minus 1117 and 395.5. And all of these values are in kilojoules. So now, what is the way to solve this? What we want to do is arrange this equation in a certain way that we end up with my initial products. And remember that if we multiply one of the values over here by a negative, what is going to happen is that you're going to switch positions, right? So I want to get 3 of iron 2O3. And over here I have iron 2O3. That is the only part in my equation where I have that compound. So, and I want it to be in reactants. So the factor by which I'm going to multiply it will be minus 3 halves. In that way, the 2 and the 2 are going to cancel out, and I'm going to end up with only iron 2O3. Okay? Now, same thing over here with CO gas. I want to have only one of these guys. So, and I want it to be in the reactants, not in the products. So I'm going to multiply it by a minus 1. Recall, multiplying by minus is like switching the equation the other way around. Now, for iron 3O4, what I want is 2 moles of this. So I multiply this equation by 2. And for CO2, over here, I have this quantity, but I want the CO2 to be in the products, not in the reagents. So I simply multiply this by minus 1. Okay. So if we do all of these multiplications and we add up the resulting equations, you're going to find that the reaction it is going to be the same. So, for example, in this case, I'm going to first write down all of the reagents. We are going to have 3 of iron 2O3. I'm going to omit the states just to have everything as clear as possible. Then I'm going to have CO gas, all of the reagents first, plus 6 of iron solid, plus 4 of O2 plus another one of O2. So instead of 4, now we're going to have 5 plus 1 of carbon solid. As I said, only one of the carbon. And those are all of the reagents that I have. Now let's see what are going to be the products. The products over here is going to be 6 of iron solid coming from the first equation plus 4.5 of O2 erase this a little bit. 4.5 of O2 plus 1 of carbon plus 1 half of O2. 4.5 plus 1 half is going to be 5 of O2, so I can erase this guy directly and put the correct coefficient. 5 of O2 plus carbon. Over here, I'm going to have iron 3O4 and 2 of this guy. And finally, I'm going to have CO2. Let's see what cancels out. 6 irons cancel with 6 irons, 5 oxygens with 5 oxygens, carbon with carbon, and I end up with my original reaction. That means that the delta H is just the sum with the coefficients that I put over there, and the result is minus 41 kilojoules. And that would be all for part A. For part B, we simply need to get the standard enthalpy of formation for carbon dioxide, and as I mentioned, that is simply the inverse of this reaction. So the standard enthalpy of formation of CO2 as a gas is going to be equal to minus 395.5 kilojoules. And that will be all. Thank you very much.